I'm Brooks Librand. I work on the Remix team. If you have questions or comments about Remix and React Router, feel free to reach out to me afterwards or yeah, come chat with me. I'm always happy to hear feedback and answer any questions I can. Yeah, really quickly, I just want to talk about our latest release in React Router is version 7.2.0. That middle number is always, that's the best number to go up. That means you get new stuff. So it's always very fun. We now have a type-safe href utility, so you can have type-safe links that are auto-generated, which is really nice. It's something people have been asking about for forever. So now you can make sure that you're not breaking your links on people, that when you are trying to navigate somewhere, you're going to the right place. So that's a pretty cool, nice utility. We also added a bunch of just fixes and updates to how our pre-rendering works. Pre-rendering is like static site generation. You might be more familiar with that term. So a lot of really quality updates there. If you haven't played with React Router's spawn mode or pre-rendering, that's a fun little feature to mess with. Allowing a loader on root in spawn mode is really helpful. So you can actually like load data before you build for spawn mode. And then also a couple other minor changes, a bunch of patch changes. So we've been spending a lot of time really trying to fix bugs. Whenever you do a major release, there's always a nice fun follow-on work. So we really have been trying to spend a lot of time fixing all sorts of issues. If there's still issues, obviously open up a ticket, because that's how we fix them and know about them. And a couple unstable features that people are pretty excited about. I'll skip that one. Unstable split route modules. We should have a blog post coming out tomorrow, so stay tuned on that one. But if you're not familiar with that, what that is, basically it makes spawn mode even better. It splits out your client loader from your components so that you can start loading even faster, and it's all like free. You don't really have to do anything. You just flip on a flag. So that's a pretty cool one. And then also the unstable Vite environment API, which is very exciting. Doesn't sound that exciting, but it is very exciting because it is one further step that we need to get to React Server components. We needed this Vite environment API. So fun stuff coming along, and we should have another release tomorrow, but I won't be able to talk about that for another month. So you can go read about it if you want, or you can just wait 1 month and hear me give a really bad recap. Your choice. But I think with that being said, we're going to invite Lucas up to the stage.
We're going to talk about authentication. I think I just would like to introduce myself a little bit. I am Lucas, for those who don't know me. I've been a software engineer for 3 years now. I work at a startup called Trinsic. We build identity verification software. So we're building like an identity acceptance network. This is a fancy way of saying that we want to be able to accept digital IDs instead of physical IDs when verifying people online. So we're building an API for that and integrating a bunch of different identity providers and partners to be part of that network. So I've been dealing with authentication and a lot of the stuff that we're going to cover here today for quite some time. I think the first big feature that I've ever worked as an engineer was building a simple auth service for this government agency that I was working on at the time. I am going for breadth here. I'm not going for depth, all right? If there is something you would like to go more in depth, I'm happy to talk more about it later. You're happy to talk to over Discord, happy to point some resources that have helped me. I will go a little bit more into depth in things that I think are more important or more relevant. But like I said, it's breadth today, all right? Okay, so let's get started. I think the first thing that I want to talk about is digital identity. Authentication has everything to do with identity. And when we think about digital identity, you usually think about, these icons don't mean anything, but usually think about things like a profile of someone, location information, picture, address, contact information, maybe bank account. This all definitely builds up what is the identity profile of someone. But for today, I would like us to expand that a little bit more and think about identity in the sense of patterns of information regarding some entity. That entity can be a person, a user, obviously, but it can also be an organization, can also be another service, another application that is interacting with your system. So think about this digital identity and authentication. That's why we have authentication, right? We want to prove certain claims about some entities' digital identity. And then I will use identity interchangeably with this word state for now, okay? And the question, this is very interactive. I really want people to talking back to me. And this is a question for you. How can apps remember state? And more specifically, what I mean is this. So here is Etsy. I don't shop much on Etsy, but I don't want you guys looking at my Amazon shopping cart. So if I look here, for example, I don't know, like I'm really into mechanical keyboards, so I want some new keycaps. And then I find something that I like, not that one. So let's see, this looks slick. So I can add that to my cart. You see, I already have other keycap over there. And I'm not signed in, right? So if I close Etsy, but then open again, Etsy remembers what I added to my cart. In fact, when I came in the first time, you even saw that they gave me like this little notification saying that I added this to the cart. The question I have for you is, how does Etsy do that? Cookies, browser storage. Okay, so let's think about browser storage. I like the cookies, but we'll go back to that in a second. What happens then if I come here to my DevTools and disable JavaScript? Do you think Etsy will remember? We'll see. It still remembers, right? Like obviously, I just refreshed the page here. But if I close and open again and disable my JavaScript and then navigate to the shopping cart, it still knows. The answer is really this idea of cookies. Is tied to the idea of cookies. But what I want to emphasize right now is this idea of sessions, right? Etsy is keeping a session on the server side about some things I do. It stores some of the information, some of my patterns, some of the things that I do on the website tied to this session in the server side. And whenever I visit again, it's able to look at somewhere in my browser where that session, identifier is, ties that back to me in the server side, and then sends the information back. So this is what sessions are, and sessions are very important for authentication in general. It's a way to persist state in application. A few things about sessions. They usually have identifiers. They have also duration. Another important things that I made sure that I would remember to talk about with you guys is they are the building blocks of every authentication and authorization service and feature, right? So just as important how long the session lasts and how you identify a session is this idea of how you will invalidate it when the session is finally going to be over. In the case of Etsy, it may not be on their best interest to just invalidate the session. I think as long as I don't clear my cache and cookies, this is going to stay on this cart for until the end of the universe. But always think about sessions that way. It has identifiers, so we can tie back to the session. It has a duration, and we need to have a mechanism to invalidate the session whenever it's over or whenever your website tells that it should be over. In the subject of identifiers, we have then tokens. For the purpose of this talk, I will say that tokens are random session identifiers. There's a little bit of caveat there, as we're going to learn later on with JSON Web Tokens. They're not necessarily random, but the idea is a token ties back to a session so you can identify it somehow. All right? They have to be generated securely in a server side. Okay? The security that we're talking about here is anywhere between 15 bytes to 32 bytes of random random information there. More than 32 bytes, definitely going to be more secure, but then you start have like marginal benefits for making it more secure than 32 bytes. So when you're generating tokens, like random tokens to tie to your session, try to be within this range of 15 to 32 bytes. Again, JWTs or JOTs, they are a little exception of that because they have like their own, mechanisms and their own little quirks, and we're going to talk about them later. But tokens, because they are identifiers of a session, you can use a token to authenticate a session, to verify that session, and to invalidate that session. If you're doing your sessions right, all you need to do to delete it is to delete the token. Okay, and the same thing with the tokens. If you're designing a sound session, a session service, to invalidate it, it must be as simple as deleting the token tied to it, right? And then you can think about other mechanisms to delete the information tied to the session and things like that. Cool. Now, going back to digital identity, we now introduce these two terms with tokens and sessions, which is authentication and authorization, right? I like to think about authentication this way. Is this user really who they claim to be? A user or a system will have claims. He claims that, my name is Lucas, I have this email, I know this password, and other claims that the user may have is, I am authorized to see these resources, right? These are the claims. Authentication is only worried about verifying that those claims are true. That's it. Authorization, on the other hand, is concerned with verifying that certain of the claims that you're making allow you to have access to resources. So it's not so much worried about who you are or if you really are who you claim to be, but it's worried about, can you do the thing that you are claiming you can do, right? A good analogy of this is thinking about a passport and a visa, right? Passport can open the doors for you to go to other countries. You just go to the border, the country will look at the passport, and depending on how the policies of the country are, they might just let you in. They just want to verify your identity through the passport and let you in. There are other countries, the United States is a good example. In the United States, there's a several list of countries where the United States actually require a visa to come in, not even to visit. This visa is a stamp on your identity saying you are allowed to enter, right? This is the authorization. So the border patrol officer, when it's at the border, is looking to verify your identity, is authenticating you. But then if you come from like South America, like I do, they're also looking for the stamp saying that you are authorized to enter, right? So verifies your identity first, authentication, verifies your permissions, second, authorization. Okay, now here begs the question is, how can you, a user or a system or whoever, prove that you are who are claiming to be? We use this idea, these are all abstractions, okay? This idea of factors of authentication. We have many factors, but the most common factors that we see out there in the wild are these three. It's a factor of knowledge, meaning that the user knows some secret that is shared between me, the authenticator, and the user. A password, security question answer, maybe an API key for some API service. But it's a knowledge, it's a secret that we both share. And then I am the authenticator. If I'm relying that as a factor, I am basically saying, as long as this person knows the secret, I'm going to let them in. Possession is the second factor. They're not necessarily in any order, but you can start thinking that ones are more stronger than others. But possession is this idea that the user possesses something that only the user can possess. So if the user can prove they are in possession of some kind of device or some kind of, whatever, I'm going to let them in. This is where, there's some debate on that, but this is where, for example, social authentication kind of enters into place. Although social authentication overlaps a little bit of knowledge, but the idea is, if you have a Google account, and if you can prove to Google that you are who you claim that you are, I'm going to trust Google that account that you authenticated with Google, you can come inside. Even better example is a security key. Have you ever seen like those Ubico keys? You put in your computer and then you just touch it, and then it lets you in. This is a possession. You need to be possessing physically that security key in your computer in order to get in some other senses. One-time passwords, etc. I digress. And then comes to this other important factor is inherence. Inherence is this idea that the user has some inherent characteristic or attribute that only that user can have. Your face, your fingerprints, like some very advanced systems, like maybe your iris in your eyes. This kind of thing. Something that only you possess can be used to prove that who you are. A good authentication system uses a mixture of these two. Okay, I'll be honest with you. If you implement a simple email and password authentication and just add a second factor authentication with one OTP codes, or maybe like an email validation, you should be good to go. You will cover maybe 80% of all the attack factors over there of people stealing accounts. But this idea of factors are important when thinking about designing your authentication experience for the user. One-time passwords are notoriously bad for user experience, but they're super safe, right? Passwords are convenient, especially for using a password manager, but they are not as secure. So these are trade-offs you must be thinking about when designing your service. So I talk about email and password. So here is another little exercise. So I like, my goodness, today we are so positive. I'm gonna log into Blind, a beautiful place, as you can see. And the way they work, they only have, oh my, any new place. They are not very friendly to 1Password, apparently. I'm gonna just open my 1Password over here. There you go. And then I'm gonna get in. All right, it's a simple email and password. All right, what adding green cards is life. Yes, it's so positive. So let's scroll down a little bit. There you go. This is a little bit better. No, maybe not. Right here. There you go. A little bit better. All right. How does this work? How does email and passwords work? How can you authenticate users like that? How is this usually designed? Does anyone have a clue? Cool. Beyond hashing, how does it? How does, like, sure, is my password being verified each time? Or basically, I'm thinking about going back to the session, right? How do you think the session is stored, or what is used to identify the session? That's good. Sorry, I put in a spot. I want you guys thinking about the flows of a simple authentication, right? To us, it's pretty, and most of us know that you need to hash passwords. So I'm not gonna go into the security of that. But I want to think about the flows, right? You enter username or password, you send the credentials, you verify that those credentials are right with the hashing and the salting, and then you generate session ID. That what you choose to be that session ID is important, right? If you're just thinking about random tokens, remember to be, a token that it's generated securely, that it has at least 15 bytes of entropy, and then you can use that as your token. But then here's the interesting. You talked about cookie earlier. That's probably how Blind is doing. Like it generates the token, creates a session on the server side, and then sets the cookie of the request to be that session ID. Now, the way you set the cookie needs to be secure. Obviously, it needs to be over HTTPS. Otherwise, there's no point. You do not want people getting access to the session ID. You don't. So that's why you put it in cookies and not in somewhere else, right? And then anyway, you create a cookie, you set it, the authentication is successful. If it isn't, do what you need to do. But whenever you make the authenticated request, the token needs to be sent back with that request. So you can verify that token exists. You validate the session ID. you go, and so forth. Logging out, again, should be as simple as just the user clicking a link in your server, figuring out that, okay, this user belongs to the session. All I need to do is to delete this token. And then every time this token shows up again in the future, I'm not going to find it. It's invalidated. Cool. I answered some of these questions here, right? Like, but when you're thinking about emails and passwords, like simple authentication, and just any authentication in general, you should be thinking about these questions. Where should we create the session? Should we set it a cookie? Should we send the token back to the user and then let the client decide where to put it? Don't do that. Where do we store it, right? How do we end it? And, how will the client send this token back to us? That's why cookies are so convenient here, right? Cookies are always included. Once the server sets the cookie back to the client, cookies will always be included in subsequent requests. If you don't know what cookies are, they're just chunks of information that servers create, and they tell browsers in the response, hey, you need to set this cookie with this information, and the client will do the rest. And then the client will include all cookies you have in the requests, right? They are the preferred way of storing session. Do not put cookies in the local or session storage. Why? Because the local storage and session storage, I guess, they're not protected. Like, someone who has access to your user's environment can go in there, can copy the cookie, and now therefore they have access to all of the resources the user has access to. They just copy the cookie over to somewhere else. Again, simple practices prevent 80% of the attack factors, right? Putting things on cookie, ensuring that the cookie is secure, is only being served over HTTPS, is a good start, okay? So don't put tokens in session or local storage, please. And then invalidating a session. If you designed everything the way it's supposed to, deleting a session token should basically invalidate the whole session, and the user should be logged out. If the session gets leaked and you have a way of detecting that, if the session token gets leaked and you have a way of detecting that, it's easy. You just delete the you just delete the token from the server side, and whoever has access to it cannot use it anymore, right? If security is critical, when you're logging a user out or when you're validating a session, it's recommended for you to delete all session tokens related to that user. If your product is something like Facebook or something, I wouldn't worry too much about that. But if it's something super critical, maybe like a financial system or something, something that bothers me with, for example, Azure. Every time I open a new tab, I have to log in Azure again. It sucks. But I guess they want to be secure, right? So the session is limited to that tab of the browser. But anyway, and also make sure that you can't use tokens, reuse tokens, and no session on my computer or on my phone, they should not be using the same token to validate them. This brings to now shifting gears a little bit. Kid couldn't think of like a nice transition to this other topic, but so here we go. This is another question. How can my app access a resource in another service or app? I'll give you an example. This is more family friendly. See? You see my calendar. This is pulling directly from my Google account. How does Google does that? Do you know? Does anybody have a clue? Do you care explaining how OAuth works, Rez? Or just briefly. I'm gonna more in depth, but. Awesome. Yeah, that's exactly it. A little trivia for you. Before OAuth was standardized as this protocol, people actually passed their credentials to the services that needed access to it. So like if I didn't have OAuth here, if Notion for some reason had bad engineers and they didn't know what OAuth was, but they probably could solve, the way that we could probably solve this, this problem is just asking my Google credentials. And I could trust Notion that they would be nice with those credentials. And Notion could just use them to, get some kind of token, create a session with them, and then every time I need to access my resource from Google in Notion, I would be able to. But then Notion needs to manage now my credentials with Google. This is bad. And this still happens today, okay? In fact, this happens when a lot with banking systems, but I guess I just have to trust they do a better job there. But you're right. OAuth, this is the flow you were just explaining. Very simplified, obviously. But my app will request the authorization to the third party. The third party will give me like some kind of redirection mechanism, so I can tell to my user, hey, you need to authorize with this other service that you want to integrate. The user then, goes that, will either open a pop-up or get redirected, whatever. But the user gives authorization to the third party. The third party then grants me an authorization code. And then I can use that code and exchange it for an access token. And with that access token, now I am authorized, my app is authorized to make requests to this third-party server and access its resources, right? And then I can give this to the user, and then I can show the calendar in the case of Notion. Few important things with OAuth. It is an authorization protocol. It's not an authentication protocol. I feel like when we talk about, logging in with GitHub or logging in with Google, we usually just put all of this together like, oh, this is OAuth. OAuth probably is being implemented in the background, especially if it's a simple integration, like I'm going to show at the end. But remember, it's for authorization. That access token doesn't give me information about the user. I still need to use that access token to get access to resources. And then once I have access to resources, then I can create an account from a user and fill the profile on my website. But I'm not authenticating a user using OAuth, okay? I'm just getting authorization from a third-party service. And now on behalf of the user, I can access some resources. OAuth uses redirection a lot. When I create an authorization request, usually what OAuth is going to give me, OAuth protocol is going to tell or prescribe is that the third party will send me a URL that I have to send the user back so the user can, authenticate with them. But anyway, the code also is granted given on a client ID. So my app needs to register with the third-party app. And then the third-party app will give me a client ID so they can tie back to who I am. And then will give me a client secret. This is going to be like, that knowledge factor that they can trust that when I send requests to them, because I know that secret, they can trust that it's me. Then, we can go into and have an argument whether this is secure or not, but I digress. This is how it works. Each authorization is scoped. You can, this will depend on the third party. The third party that will kind of prescribe what scopes you can have access to. But whenever you're creating an authorization request, you need to say, I want access to this resource, to this other resource, to this resource. And then whenever you get an access token, your access token will be scoped to the resources that you initially requested. Okay. One important thing with OAuth that it's not included here. I have to trust, my app has to trust that when the user gets redirected back to me with the authorization code that I can exchange, I have to trust that, the origin of the redirection is good. How do I do that? OAuth supports me when I'm creating this request authorization over here. OAuth lets me to specify a state. That state can be a token that I generate. See tokens again? So that state will remain the same all throughout the flow. And when the user gets back to me, the state will be there. And then I can just compare. And then I can trust, okay, this came from a source that I expected to come right now. So when you're building this, don't forget the state parameter because it's not required, but it is best practice to use. Okay. So the other question is, and you don't need to answer that one, how can I let my users sign in with other identity providers in my app? Like I said, OAuth is authorization, right? I know it has auth in the name, but that's the problem of using auth, because it can either mean authentication authorization, but OAuth is authorization. Sorry, I kind of yelled there. So what should I use if I just want authentication? If I want to authenticate a user? OpenID Connect. This is another protocol or standard, whatever you want to call. It's built on top of OAuth. In fact, most people refer to this as if it is OAuth. It's not. There's some few differences. I'm not going to go too in depth into it, but I recommend you looking it up. Okay. The key difference that I'm going to emphasize here is that if we go back real quick, while OAuth gives me a access token that I can exchange for the resources I want, OIDC gives me a ID token. This ID token now contains the information about the user. So I no longer need to just fetch the resources that I want. The token that they give me back, this ID token, now contains some information about the user that I can work with. And then I can use this JWT, this token, in my own application to verify, the actions of the user. I can use it to create my own session. And then I don't really have a need of keeping information about my user in a separate database if that is something I don't want to do, right? You probably, in most use cases, you still want to, be able to have keep track of who your users are and tie them back, but you don't really need if you only want the social authentication aspect of it. That's essentially is the main difference. There are other differences that are important, but then I could do a whole presentation OpenID Connect, and I'm not going to go, I don't want to do that right now. But there's a difference, so just remember that. Are you thinking about OAuth, just authorization, or are you thinking about OpenID Connect, where you actually care about authentication? And then, because we were talking about JWT, here comes JSON Web Tokens. They serve the same purpose that we've been talking about, all right? But they carry state with them, right? There's a payload. JWTs, they have three parts. They have a header that tells you what algorithms and how, basically gives them some information of how the token was generated. They have a payload that contains information about the user, about who created it, who created this kind of stuff. And then you have the signature, that is the part that you can check to see if this token has been tampered with, if it was issued by who you expected it was issued, and the header gives information about how you verify the signature. JWTs, they are not secure by default. Anyone can look into the payload. Anyone. The signature is not there to encrypt the payload. The signature is only there to check if the payload has been tampered and if it was issued by who expected it was. But the payload itself is public to whoever wants to see it. It's just base64 encoded, right? It's just a different encoding. You just decode that and there you go, you have it. But if you want to verify a JWT, then you need to check the signature. The header will give you hints how to do that. You can cryptographically sign the payload, so you can actually encrypt it. And then this is where you're going to start heading into the spheres of JSON Web Keys and JSON Web Key Services. Sorry, I inverted here. The payload, when it's encrypted, is JSON Web Encryption. When the signature is cryptographically signed and you want to hide the keys, you're usually going to rely on the service of JWK and JWKS. Basically, I want to verify the signature of this JWT that came to me, but that signature is not just public anywhere. So I can go out there in the internet in a well-known endpoint that the third party has. I can pull down the public key from there and trust it comes from them because of HTTPS. And then I can verify the signature cryptographically that way. And then I can also encrypt the payload into a JWE. And you would use cryptographic keys like JWKS to decrypt it as well. The question I have here now, and you can answer that. Like, if you haven't seen this website, by the way, this is pretty cool. You can play with it. I think anyone who have worked with JWT in the past have already seen it, so I'm not going to spend too much time into it. But you can see, the algorithm types, the types, the secret to verify the signature, etc. Cool. Going back here, the question is, when do you think you should use JWTs? And when you think you should just use normal sessions? And let me give you more context that I think I missed here is JWTs are using, or JOTs, they are used to basically carry or authenticate stateless things, right? You don't need to create a session to use JWT. JWT itself presents the session, right? It has a signature. It has some component of it that's kind of random. So JWTs are kind of like mini sessions in themselves that you just carry around and pass around, right? So given that context, when you think you should be using those versus a session? No right answers. No, that's a lie. There's a right answer. Yeah. What else? Yes, you can use it for multiple services. Sessions is just restricted to that particular client, right? If you're doing it correctly. This is what ChatGPT said, based on the, like on the dump that I gave to it, I don't know. Essentially, when you need stateless authentication, for example, APIs, like you have a bearer token, you put on the header, that bearer token can be a JWT if you need to carry that state somewhere and you don't want to keep a cookie in a particular device. It's used for that. SPAs in the past, at least when I was first learning how to build SPAs, it feels like every authentication strategy that for SPAs relied on this idea of like getting a JWT, saving it securely somewhere, and every time you made a connection to the backend, you send it together in the header, right? Is it the best way of using it? I don't know, but it's a way of using it. Microservices, talking to each other. You can authenticate each other with using JWTs. It's a good use for that. But for every other traditional server-side application or just normal website or normal web application, find great session that needs sessions and control the session. Use sessions. Like I said, you keep a session for every device or for every granular access that a user has. And then, you validate that session on the server side, and the server side can fetch the data tied to it and then feed it back to the client whenever he needs. So if you're building like an API, JWTs are great. But if you're just building a normal web app, stick to sessions. It's probably going to be better. Like I said, JWTs are not secure. The payload in them can be accessed unless you're encrypting it, obviously. But anyway. And then since we talked about cryptography, we get to this part, which is pretty cool. Public key cryptography. It's a mouthful for me. Or asymmetric cryptography. You know the drill. How does it work? Does anybody here a crypto expert? Or no? Go ahead, Nick. Say that again. Yes. It's essentially that. Here's like a little nice diagram. You have a super secret private hidden message. You encrypt it using your public key that is part of a pair, okay? And then that will make it into a gibberish. And then, I have a private key. I can use that to decrypt the message you encrypted with your public key, and then I can see the original contents. We usually talk in this concepts of public and private, right? Like public, I can throw it in on the wild and anyone can send me messages now and I can read, that's fine. And there's some sense to talking about it like that. But the inverse process is true. If someone, if I sign a message with my private key that public key over there, depending, obviously, it always depends how these keys were generated, but because they are a pair, but you can kind of like interchange, and we're going to see how that plays in some of authentication concepts. But they are a key pair. The keys get generated by the same origin. You give your key to someone, you keep your private key, or vice versa, and then you can trust an interline of communication. Do you think we can use that for authentication? And if we can, what kind of authentication factor is it? Possession. That is a good insight, intuition, and I would agree. I think it fits more that. Now I add to this that public cryptography doesn't depend on like the subjective things like, oh, does the user know something, or like is the user has his phone nearby, or did someone cut this user's finger? Right? Public key is only concerned with math. That's what it's concerned with. Like, like you use modular arithmetic. It's all based on physical and mathematical properties that can be verified and will always be verified. Essentially, what this means is, if I use a password to go on a website, it doesn't really tell that I am the person, because someone else can have access to that. The same thing with, like my email account. My email account has been compromised and I get a magic link into my email to authenticate it somewhere. It doesn't really tell that I actually have that. And I guess with just keys in general, it's the same. Like if someone steals my key, it doesn't really tell. But looking specifically on the key and only being concerned with verifying the cryptography there, you cannot spoof it. Like if you give a gibberish message to someone that was encrypted with a key, and someone is able to decrypt that, 100% that key is the one you were looking for, right? Like if you forget about the user using, obviously, but if you think about the key itself, only that key can do that, right? But then when we put people in the mix, of course, it starts becoming subjective, and it just falls down into possession again, right? Like does the user have the key? But to what concerns the key itself, it's 100% secure. Only that public key can verify a message of the private key, and vice versa. Anyway, so yeah, we talk about this. So how would you think I can use this concept to authenticate my users? Yes, and that is the main idea behind passkeys. So if I can try a demo over here, I can sign in with a passkey, and then, I do that. And there you go. Here am I. You see, I didn't give any information about who I am. It just knew, because when I created this passkey, obviously it tied back to my information. But the way the passkeys work is relying on that idea of public and private keys. If I go back over here, WebAuthn, which is the specification where passkeys are built upon, prescribes how public key cryptography is used, right? Keys are credentials in WebAuthn. A passkey is a type of credential. And specifically, like we emphasize passkeys because passkeys is a type of WebAuthn credential that you can use for passwordless authentication. So I don't need to provide any information about myself. If I have a key registered on this authenticator, which is my computer at the moment, the website can tie that key back to a user information that I created when I registered. And then he knows. I don't need to put my email. I don't need to put a password. WebAuthn was created to solve the multi-factor authentication, try to make it a little bit better. And then someone thought about, well, what if we can get rid of passwords altogether? And then passkeys, this idea of passkeys and resident keys came into place. If you asked me 6 months ago, and actually, I'm going to say that. I'm just going to show this first. This is a passkey flow. It's pretty small. But the idea is the user starts an authentication. The client will tell to the server, all right, the user wants to authenticate. I need you to create a WebAuthn authentication session. Generate for me a challenge based on these options I'll give to you before. So then the server generates a crypto challenge, generates a random token, here tokens again, creates a WebAuthn request, creates a session in the server side so it can keep track of what's going on. It returns a WebAuthn request with the auth challenge, and then the client will pass that information to the authenticator. In the case of passkeys, what's going to happen is the authenticator will enumerate to the user all the passkeys available for that particular domain on the user's device. And then the user can now choose which passkey he wants to use, right? But the idea for either just a normal WebAuthn flow versus passkey flow is the same. The user will then either select the key or just straight give approval, but the user needs to give a gesture to say to the authenticator, yeah, you're good to go. That is a PIN, that is a Touch ID, that is a Face ID, whatever the authenticator supports. The authenticator approves that and then signs the challenge and adds some more information to it about the key that was used, etc. And then sends that back to the client forwards that to the server. The servers look at the request, the response, compares with the challenge that he issued originally, checks the signature. If everything passes, the server can create now an authenticated session for the user. And the user then can have access. That's how passkeys authentication work. That whole idea of like generating a session with a public key, verifying that the session, verifying that the challenge, sorry, I used session, but I wanted to use challenge. Verifying that the challenge was signed properly. This is public key cryptography implemented for an authentication flow, right? This is how passkeys work. Should use passkeys everywhere then. They're so cool. I love passkeys, but they kind of suck after a while using them. It's hard to get a good user experience with them. If you asked me like this 6 months ago, I would be super bullish. Yes, stop using passwords. But if you think about passkeys came to replace passwords, but passkeys rely on this idea that you have your passkey that is synchronized across multiple devices. Now you're locked in. If I want to use the key cloud chain, I need to have a Mac OS and I need to have an iPhone. I break that mode. I have an Android phone. My passkey on this device will never be synced to my personal phone. How do I make that synchronization? Well, you use some form of password manager. Right, but I was using password manager from passwords. And so here's the problem. And then things you have to think about. What if I lose access to my passkey? How will I recover it? Well, you have to implement a recovery flow. How are you going to do that? We can do email verification. Why don't you just do that for authentication then? So when you're building a user experience around passkeys, you have to think about these little quirks that may not make super sense. It's, especially for older population or people who don't have access to really good devices, it also creates a barrier there. But if your app serves just a few, it doesn't need to operate at scale, it doesn't need to be super secure, but you want to go the extra mile, just do email and password and put in a multi-factor authentication, right? Just do an email verification, do a one OTP. You can even use WebAuthn. The nice thing of just using WebAuthn versus passkeys is that the user can create as many keys as it wants in any device they have, and the key will live on that device, will not be synchronized with anything. And anytime you need to verify that the user, like as a second factor, that the user is getting in, they can use whatever device they have access. So I love this because it is true. It was supposed to replace them. We were supposed to replace passwords, but obviously it did not. And he just hates you. Okay, so I talked about a lot of things. And I open for questions later. We can go over it a little bit more. But we're here to talk about React Router. How can we, what is a good strategy for that? I'm pretty new to Remix. I'm pretty new to React Router. But I am pretty happy with the tools available for doing authentication. I don't know if there are others out there, but this one that I've looked at, Brooks recommended. It's pretty good. It does It does the job really well. The nice thing about remix-auth, it's a very declarative approach. It's based on a strategy pattern. You basically, here, you define the schema or the model that you want the authenticator to return to you, which in this case is just a user. And then with that authenticator, you just define a strategy. The example here is for just email and password, right? This strategy needs to return a function that in the end will return that model you established over here, in this case, user, right? And then you know, you can use remix session helpers to create the session on the server side, and then you can, you know, protect routes by looking if the session contains the user, this kind of stuff. So very declarative. The nice thing about remix-auth too is that the community is great. This is like a discussion going on in the repo, and these are all the strategies that were created for remix-auth. I think Sergio created more than that, but these are like the three big ones, and if you pick one of these two, you're good to go. For strategy, auth strategy, like you even have like Discord here somewhere. There's Spotify strategy. You can use any strategy you can think of. If it already exists in form of a community strategy, you can implement yourself because this library allows you to do that. And then here, for the sake of our project, here's a little demo. I made it really, really small just to show. This is a GitHub strategy. So I'm authenticating using GitHub. I'm using OAuth here. This is not Open ID Connect. I don't think GitHub really supports that. If it does, even someone else, let me know, because I think that would be cool. But you see, I have over here where is my authenticator? Oh, it's here. Okay, so here's my user, right? This is the model that I defined. It has these properties over here. So the GitHub strategy, it will take the GitHub credentials that I created in GitHub. If you go to settings, yeah, I'm going to do that now. So you go over here and then go to developer settings and then OAuth apps, right? You can create a new OAuth app. You can give a name, URL, etc. And then I can go here. There's no secrets showing. I guess the end of the secret is showing, but whatever. But okay. You know, here's a client ID. Here's a secret. Use that. Here you define the callback URL you're going to need. There you go. It's localhost. So I pass that in here, pass that information over here. And then I have a verify function. This will be called whenever the user starts the authentication. And I'm so sorry. This gets called whenever the user finishes the GitHub authentication, right? Because then I have access to the token. Remember OAuth? OAuth gives you an access token. That's what it is here, access token. I use that to make an API request to GitHub, fetching information about my user. And then, you know, this is the GitHub user, and then I return user over here. Cool. If I look at my login page, there's only a link that gets me to this resource route in Remix. The resource route, all it does is gets the authenticator and say, authenticate using this strategy. Here's the request, right? And then this will send me to GitHub. GitHub will authenticate me, will redirect me back to the callback route. And the callback route will get the, you know, we'll get the session based on the cookies that I have, if I have any. And then I am going to finish the authentication, passing this request, using the GitHub strategy. Now I have access to the user. Now in my session, I set the user, and then I set the cookie by committing the session, and then redirect it to the homepage. When I want to log out, what I do, I just get the session again and destroy it. Done. Here, if I already have the session and the session has a user, I redirect it to the homepage. I don't want the user to be able to see the login page. And the same is true over here with login, right? Like if there is no user, then I want the user to go to the login. And then if there is, I'm just going to return the data of that user. And then this is This is some of the session helpers that Remix offers. So I'm just basically creating cookie session storage in the server side. Like again, these are recommendations of how making cookie secure. I will recommend a resource for you to read what each one of these does. But this is probably what you're going to need for 80% of the cases, okay? And that's it. So if I run this, see, oops, wrong key. If I run this right now, oh yes, because I am on this this Wi-Fi. I've had that problem before. I'm not gonna be able to show these to you guys. You're gonna have to trust me. Yeah, I could create like a hotspot here if you really wanted, but I think we're running on time. But trust me, it works. I'll send you the repo and you can run as long as you create the app. But that's essentially it. If I want to show some other interesting strategies, this is the OAuth strategy. I am 100%, no, 100% too much. I am like 95% sure that Sergio used this strategy as a base for the GitHub strategy. And here's the OAuth, the things that we talked about. Here's the client ID of your third party. Here's the client secret that your third party gave to you, right? Here's the authorization endpoint you need to hit with your third party. And then here's the token endpoint that you're going to use to retrieve the access token once you have the code, the authorization code back. And this is the redirect URI, the place where your user is going to be redirected to with the code to retrieve the access token. And then token revocation endpoint. We didn't talk about this, but OAuth does prescribe that, if you're building a OAuth service, you need to have a place where your tokens can be revoked. This is the endpoint to do that. Here are the scopes, right? OpenID. Ooh, what is this? Does it have to do with OIDC? It does. Like here's the email, here's the profile, etc. And then some other crypto interesting things. That's how GitHub works. Like the GitHub OAuth works under the hood like this, right? Like if I wanted to create my own custom strategy using OAuth, I could use this and then just hard code here some specific endpoints for that third-party service that I have. Another cool strategy is the WebAuthn strategy. So this is Authenticator. You need to save this somewhere because you need to remember authenticators. Your public key is derived from that, by the way. Right here, credential public key. So you save that and you use that to sign your challenges. And then this is how the strategy works. This is a very basic WebAuthn request. That's what a WebAuthn request looks like. This is what you end up feeding into your authenticator. Cool. You just use that, and you can do the verify. Here, he is handling both registration and authentication, and then he creates he creates this at the end, so you can register users. Pretty cool library. Very easy to customize it and create your own strategies. If you're using Remix and you want auth and you don't want to deal with too much hassle, use this. Okay. Few other things before we go. Some resources. The Copenhagen book is fantastic. It is really great. It covers authentication in practice. It's not going to talk about theory like I did today. It talks about how you actually do these things in a safe way. It goes over email verification, talks about OAuth, talks about open OIDC there, MFA. And then this is another good resource. You want to be familiar with this if you want to be secure, right? So if you want to implement authentication, this is a good place to start, very practical. If you're interested in passkeys, this is a pretty good primer. I gave a talk months ago about price passkeys. I can point you to that as well. And then this talk in specific that I'm going today is based very heavily on Identity 101 by Tyler Clark. Tyler, he lives in Utah. He's a great dude, and he gave this at a Utah JS conference a few years ago. And then Web Authentication API is a course on front-end masters that goes more on like these first principles. And then Max here really goes deep into what the capabilities your browser already have. So you need capabilities that you can leverage to implement authentication end-to-end. And yeah, thank you so much. If you have any questions, let me know. I'm happy to answer them.
If you put it in a cookie, you've got the cross-site request forgery. But if you put it in local storage, you got cross-site scripting. What's your thoughts on that?
Yeah. I'll be honest with you. I didn't feel like I needed to worry too much about cross request forgery if I'm just following some best practices, right? Like I'm not like a cookie master. So like I don't really understand exactly how this attack really works. I will point a good resource. It's the Copenhagen book again. You go in there. It talks about it. You choose your battles, man. Honestly, I know cookies are secure because it's, you just can't accidentally meddle with them, right? Like in local storage, if I can play around and find my way into local storage and see everything is in there. With cookie, I need to be very deliberate to be able to get whatever I need from it. But yeah, I don't think I am the best person to talk about like the trade-offs between this and how to prevent CSRF. But this is a good resource. Yep.
Yeah, check it out. Thank you.
Yeah.
Some talk, really pertinent to what I've been doing lately. A question kind of along the same lines, talking about those session tokens. Is it a good idea to also store those in your database? And is the point of that just like invalidation, or can they only live in the cookies and that's how they get
No,
cleared?
you need to store them somewhere besides the cookie, right? Because the cookie is just so the client can store it secure. The cookie is more like a client solution to it, and you still need to store your tokens somewhere to identify the sessions. You can use like a memory database like Redis. You can use a database. You just need to make sure that they are secure, right? Like they are created with the right entropy. I think Copenhagen books, like this is where I got the idea of like 120 to 156 bits. Translating to bytes is 15 to 32. And just make sure that when you invalidate it, remove it from everywhere. And then you should be good to go. With JWTs, they're a little bit tricky, right? That's why OAuth prescribes like a revocation endpoint, because you don't want the JWTs to live forever, especially if you lose them. But at the same time, JWTs, they carry session information in them, so you don't need to store them anywhere. Now, I will say this, because you're only verifying signature, obviously. And I will say this too, there's this idea of refresh tokens versus access tokens, right? If you're doing that, you don't want to store access tokens. You want to store refresh tokens. Because then whenever the access token is expired or revocated, whatever, you just use the refresh token to get a new one. That's what you do. Yeah, does that answer your question?
Yeah, thanks.
Awesome.
I will say, I appreciate that you explained that OIDC is built on top of OAuth. I am one of those people who just assumed it was all the same.
Yeah. Just remember, OAuth is for authorization, OIDC for authentication. But if there's no more questions, I will hop off. But thanks for having me here. Appreciate it.
All right. Thank you, Lucas. Really appreciate it. Great talk and fun to hear you change your opinions on passkeys. So that's great. Well, that's a lot of me. All right. We'll go with it. So, yeah, I don't have any other slides. Just a quick first reminder, ask if you do have a talk that you'd like to give at a future meetup, feel free to talk to me. We also have a form on our meetup, so you can submit it through that as well, and I'll get an email for that. Well, yeah, thanks everyone for coming. Hope you all had a good time. We do this every month, first Wednesday of the month, so we should be back on April, I think 7th is, I don't know, I didn't look at my calendar recently. But yeah, otherwise feel free to grab a little bit more food if there is any left, or a drink, and just hang out for a bit, and then we'll try to get out relatively promptly. So yeah, thank you all again.